Hi y'all, welcome to week 5 of distance learning. Today's focus is going to be solving quadratics by square roots. So this week we're going to look at two different methods of solving quadratic equations. We're going to be looking at square roots and quadratic formula. Just to give you a quick reminder, the word quadratic just means that the highest exponent or the degree of the equation that you're solving is 2. So for example, x squared plus 2x plus 3. That is a quadratic equation because of the exponent of a 2 that's there. So that's all it means when it says solving quadratics. So sometimes we don't have to factor to solve. We can use other methods. If you solve using square roots, then you can get everything being squared on one side of the equation, or one side of the equal sign. And then you take the square root of both sides. And then we're going to make sure our answers are completely simplified. Okay, so our first example, we have 3x squared equals 9. I want to get the x squared by itself first and then use the square root to solve. So I'm going to divide both sides of this equation by 3. So I'm going to get x squared equals 9 divided by 3 is 3. Then I want to take the square root of both sides because my goal is to get rid of this exponent of a 2. X squared and the square root of x are inverses of each other, meaning they undo the original operation. So I'm going to take the square root of x squared and I'm going to take the square root of 3. What I do to one side, I have to do to the other. Remember that whenever you are solving an equation, and you yourself put in a square root symbol, we have to put a plus and a minus in front of that, okay? So now the 2 and the square root are going to cancel, and you're going to have x equals plus or minus the square root of 3. 3 is not a perfect square, meaning that if I take the square root of 3, I do not get a whole number back. So the square root of 3 is as simplified as we're going to get. So this equation actually has two answers. You have a positive root 3 and a negative root 3. So I could also write it as root 3 comma negative root 3. So there's two solutions, okay? Let's look at the second one. So we've got x squared plus 5 equals 14. I want to get the x squared by itself, so I'm going to subtract 5 from both sides. Okay. Now I want to get that squared away from the x, so I'm going to take the square root of both sides. And since I'm solving, I'm going to put the plus minus in front of my root 9. So now these two are going to cancel, and I'm going to have x equals plus or minus the square root of 9. 9 is a perfect square, and the square root is 3. So my two solutions here are a positive 3 and a negative 3. Okay, let's look at x minus 3 squared equals 9. I'm going to move this and zoom in. Okay, so in this case, there is nothing in front of the parentheses and there's nothing behind before the equal sign. So I'm just going to go ahead and take the square root of both sides. So I'm going to take the square root of x minus 3 squared and I'm going to take the square root of 9. And since I added that square root, I'm going to put a plus minus. So these two are going to cancel. Whatever was underneath that square root symbol is going to be brought down. So the x minus 3 is going to get brought down. And then I've got plus or minus, the square root of 9 is 3. Now what this is really saying is it's giving me two separate equations. One equation is x minus 3 is equal to a positive 3. The other one is x minus 3 is equal to a negative 3. So that positive and negative are distributed after the equal sign on both. So you're going to solve these two equations separately from each other. So in this one, I'm going to add 3 to both sides. So I'm going to get x is equal to 6. On the other one, I'm going to add 3 to both sides. Negative 3 plus 3 is 0. So the two solutions I get are 6 and 0. Notice that these are not a positive and a negative version of the same number. That's okay. You can have two completely different numbers as your solutions, okay? Let's look at the last one on here. So on this one, I do have something in front of my squared term. I have this negative 2 right here. I need to get rid of that first before I can take a square root. So I'm going to divide both sides by -2. The reason we're dividing is because -2 and x plus 4, they're being multiplied together because there's no symbol in between. So to undo that multiplication, we're going to do division. So divide both sides by -2. These are going to cancel. So you've got x plus 4 squared equals -4. Now that you have a squared that's by itself, you can go ahead and take the square root of both sides. And I'm going to put that plus minus in there. So these are going to cancel, and I've got x plus 4 equals plus or minus the square root of -4. Now, y'all have done complex or imaginary numbers before. We're not going to get into it this week, so whenever you get an answer where you see a negative underneath of the square root symbol, I just want you to put no solution. Okay? I know that there is a complex or an imaginary solution, but just for the purposes of this week to keep things simple, when you see a negative under the square root symbol, I just want you to say no solution. Here we've got an application problem. So a relief package is released from a helicopter at 1,600 feet. The height of the package can be modeled by this equation. H is representing the height of the package in feet, and T is representing time in seconds. The pilot wants to know how long it will take for the package to hit the ground. Write the equation you are trying to solve and then solve it by taking a square root. So what I know is that H is equal to height. I know that T is equal to time. And I know the package is released when height is equal to 1,600 feet. And this is the equation that's going to be modeling that. Okay, so what we're going to be doing is this H equals 1,600. That's already been taken care of right here in the equation. What it's asking you to find is time, because it's saying the pilot wants to know how long it will take for the package to hit the ground. So when the package hits the ground, the height of the package at that time is 0. So I'm really looking for, if I put H equals 0 right here, how will I solve that equation? What will the package be, or what will the value of T be? How long is it going to take for that package to hit the ground? So I'm going to rewrite this as 0 equals, because height is 0 when the package is on the ground, -16t squared plus 1,600. Okay, now I'm going to solve this equation for T, or solve it for time. So it wants me to use square root method, which means that that T squared that's right here needs to be all by itself. So I'm going to start by subtracting 1,600 from both sides. So this gives me -1,600 equals -16t squared. Then I want to get the -16 away from the t squared, so I'm going to divide both sides by -16. So these are going to cancel. -1,600 divided by -16 is +100, and that's going to be equal to t squared. So to get rid of the square root, or the square symbol, I'm going to take the square root of both sides. So I have, just so it looks the way that you're used to seeing it, I'm going to take the square root on this side, and I'm going to take the square root on this side. So these cancel. The square root of 100 is 10. So what this is saying is that the time it takes for the package to hit the ground is either a positive 10 seconds or it's a negative 10 seconds. There is no such thing as negative time, so this solution of -10 seconds is just going to be crossed off, and my real answer is going to be 10 seconds. So it's going to take 10 seconds for the package to hit the ground. The problems that are on this page, these are practice just for you to kind of get a feel for how to do these problem types. The key to this is on Google Classroom, so you can go there and check your work, but make sure you use this video, use your notes to kind of help you solve these. This is not a grade. This is just practice problems for you to get used to doing the material. So when you do the assignment for this week, you know what's going on. Okay, let us know if you have any questions.